To start the recording. So welcome to day 06. A few people will be joining in as the course moves along. So let them join as they join, but we'll kick it off. And what we're going to do today is deep dive into some of the concepts that we applied in building the last app. So if you remember in the last session on day 05, we built this game called Pong, right? And we continued to advance our understanding of how do we build animated games for the Android phone. And how do we do that using image sprites, canvas, and clock and timer? We also learned how to use a database. And one of the things we found out is that App Inventor makes it really easy to use a database and incorporate it into our app. So today we are going to be practicing some of these concepts, right? And we're going to be doing these 5 practice problems. After that, we are going to do a small interactive quiz, and then we'll do a knowledge session with a few nuggets, okay? And so the first practice problem we are going to do is how do you add a parameter to a procedure? So we'll practice a little more with using the TinyDB database in App Inventor, and also how to write good procedures. So let's jump in. If you're going to code along, then I'm going to be doing every practice problem from scratch. So feel free to code along. Otherwise, please feel free to unmute and stop me if you have any question, okay? So how to add a parameter to a procedure. So first, let us just see what this app looks like. And I'm going to show this in the emulator. And what is going on here is a very simple app to maintain a to-do list. So remember, this is a practice problem, right? And what we'll do here is first, let's just see how this works. So let me say I have items to add to my to-do list, like get milk. I'm going to add that. What else do we do every day? Water plants. Yes, I keep forgetting to do that. Add to do. Yeah. What else do you want to add? Do my yoga. And what this practice problem shows us is how do we use an app, how do we use a database, sorry, to maintain a to-do list, and then I can clear it all, and then I can start all over again, okay? And so in the designer, you can see what are all the elements that this app has. It has a text box. So the text box is what I use to give inputs to the app. Then I have a horizontal arrangement to have these 2 buttons, the submit button to add a to-do and the clear all button to clear the list side by side. In order to have them side by side, as you know by now, we use a horizontal arrangement. Can you see where I'm pointing? It may be a little small, but yeah, last time I tried to zoom in, there were some problems. So yeah, do your best to follow along. And then we have a label, which is where we see the to-do list. So this is where the list is displayed. And the TinyDB component, which we get from storage drawer. So I've just gotten one instance of that. And as we know by now, that doesn't appear on the screen because it is not a visual element. It has nothing to do with the look and feel of the app. It just sits under the screen. Okay. And so these are all the elements. And now let's look at the code. And what I'm going to do is I'm going to delete all of this code as always and start writing from scratch. So add to backpack, add to backpack, add to backpack, add to backpack, and add to backpack. And let's just now delete all of these one by one. Delete, 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 delete. Delete. I think that's it, right? everything is gone. Okay, and so now if I go back to the emulator, I see nothing will happen. Okay, so save the empty screen now. Okay, now let's start coding block by block. Now the first thing we want to do is to create a global variable to hold our to-do list. Okay, so I'm going to the variables drawer and picking a global variable, and this I will call my to-do list. We can call this anything we want. And how am I going to initialize this? Yeah. So what I want to do here is actually populate it with the contents of my to-do list in the TinyDB database, right? So when I go to the TinyDB component, as we saw in the last session, every database can be understood as 4 and only 4 operations: create data, retrieve data, update data, and delete data. What we want to do here is we are assuming that there is already data in the database. If not, we'll see what to do about that. So we want to get what's in there to populate our to-do list. So let's get the block called get value. You see this block called get value. So that is how we query the database. And querying with this TinyDB basically means you tell it, I have stored a number of items. These items are pieces of information. They could be numbers, they could be text, they could be lists of numbers or text. But every item has a name or a tag, okay? So what we are telling TinyDB is get me the information that you have that I may have stored earlier under this tag. And what is the name of the tag? So I'm going to call it my to-do list. Yeah. And there is a chance that this tag doesn't already exist, right? Every tag will have a first time that it is created when I put information with it. So what happens if if the database is not able to find that tag and see any information under it? So then it's going to return an empty list. Okay. So we are using lists in this app. Lists are nothing but lists of items. And so when I go to the list drawer, I can see create empty list. Okay. And then I can see a number of other blocks to work with lists, to put information in, to get information out. Okay. To make lists, to update lists, to delete lists. So it's going to return an empty list. And so far, all that has happened is this is the first block of code that App Inventor will run. And it will just query the database to see if there is any information already in my to-do list. If not, if it doesn't recognize the tags, if it doesn't recognize the tag, it will create it and return an empty list because there's nothing in there already. And now in the next order of business, I'm going to write a function to basically take that list of items and show it in this text label. If there's nothing there, then nothing will be shown. But if there are items in there already, then those items are in a list and we'll convert it into text suitable for showing through this label. All right. And so we've gotten some amount of practice with procedures so far. I'm going to just continue to develop that. So I'm going to call this procedure get my to-do list. I can call it anything I want, right? We can call it anything we want. And what do I want to do here? I want to update the text label to show something. So what do I need to do? Where do I need to go? I go to label. And if you remember the get and set attributes of any component, I want to set the text attribute of the label to something meaningful. Okay, so let's just get set label text. And even before that, what I want to do is I want to start with a clean slate. So let's just set the label text to go to the text drawer and grab an empty string. So this is just initializing the text to a blank, right? There's nothing in there yet. Now this is a list. So what we're going to do is we're going to go over each item in that list and keep adding to this text. So keep building a paragraph out of every item that's in the list. Okay. What do we need to do that? We go to the control drawer. And since we want to go over every item in a list, you can see there is conveniently a block that says for each item in list. What's the name of the list? It's my to-do list. So I'm going to get that list. And now in this for loop, what we are going to do is update the label. So stick each new item into the list to the top of this text block every time. Okay. Okay. So we need to do some text manipulation there, and we need to set the label text to what? So every time we do this, we'll go to the text component. We'll grab the method to join. What are we joining? We are joining the new item that's in the list to whatever is in the label already. Okay. So go to the label and get whatever is in the text. And this is going to just put these items next to each other, which is not what we want, right? We want each item on a separate line. So I'm going to expand this block a little bit by clicking on the blue icon. And then I'm going to just stick a line separator there. So we've seen this before, this \n, that's a shorthand that tells the computer program that as you join these items here to create a block of text, stick a new line between them. And a new line is represented by \n, which means that, just take each new item and put it on top of the previous item. All right. And that's how you're going to get a big block of text. Give me just a moment to check how I've done it before. Yeah, it's exactly right. Okay. And so when I initialize the screen now, so far I've written a procedure to basically examine the contents of this list and then create text that we can display. We have not actually displayed the text yet, right? So for that, we are going to use a screen initialize procedure. Go to screen and grab the initialize procedure. And now what do we want to do? We just want to call this procedure, get my to-dos. All right. So label text starts with nothing. Then we iterate over the list. Each time we get a new item from the list, we just stick it on top of the previous item. All right. And so we get text that we can show. All right. And let's go back to the emulator. And now if I refresh the screen, if there's something in the database, then that will show here, but there's nothing, so nothing is shown. So actually now I want to write code to start adding items to my to-do list. Okay, so far what this is telling me is there is nothing in the database yet. So the behavior I want is when I click on the button to add a to-do. So I'll type in the to-do here as we did at the beginning. And then when I click add a to-do, it will get added to the database and it will show here under the buttons. All right. So to program this, I go to the submit button. I grab the click event of the button. Okay. And what should happen when I click on the button? It will grab whatever text is in the text box. Whatever text is there, it's going to grab that. So let's find the getter for the text box text. There it is, right? And then we want to do a number of things with the text. We'll come to that. The first thing I want to do is to check that that field is not blank. All right. So I'm going to go to controls and grab an if then else. When I go to text, there is also a function called trim, which will remove all white space from the text. And what I want to do here, white space is just spaces in text. Yeah, like spaces between words. And so if there is only white space basically evaluates to a logical false, all right? So after trimming what text is in the text box, if it's just white space, then I'm going to do nothing. Okay. Let me just start with the, maybe we need a, let's just start with this. All right. If text box text, okay. Give me just a second. Text box. Yeah. Is empty. Okay. So after trimming what's in the text box, if there's nothing there, then it's an empty string, which evaluates to false. Then I'm going to do nothing. So I'm going to leave this then blank. And in the else now refers to the user has entered something into the text box. So I'm going to add that text to the database and to this global list. All right. So let's first get a setter for the global to-do list. And this is a list, right? So go to list and find the block that actually adds a new item to an existing list. So add items to list sounds appropriate. Yeah. So the way we use this is a little different. Add items to the list. Get rid of this one. We have to tell it what list. So go to the global variable, get my to-do list, and then we have to tell it what item, right? So that item is what's in the text box after trimming it. So I'm just going to duplicate that code. So now this new item after trimming is added to this list, and we'll keep maintaining this list as we go. I also want to add it to the database. Yeah. So go to the TinyDB component, grab the store value. We are using the my to-do list tag. So I'll just copy it from there. And what's the value we want to store? It's the global to-do list that we just updated. Okay. So the previous block of code just updated the to-do list. So now I can stash that whole list under this tag. All right. So this is the logic of this app. We maintain a global variable called to-do list. Each time there's a new item to add, we update this to-do list. Then we use that to-do list to update the database, and then we display the label. All right. So to display now, we'll use the procedure. Get my to-dos. Stop me if you have any questions. Okay. And if I've done this right, there's no guarantee with coding. So if I've done this right, then what should happen is we should be able to now add new to-do lists to our app. Okay. So again, running this in the emulator, let's just add get milk, my all-time favorite. Add a to-do. Yeah. So do you see what happened? So get milk got added to the to-do list. Let's add something else. So what is happening is after it added get milk that I typed in the text box over here to the to-do list, it's still sticking around in the text box, right? So we don't want that. So let's make that code change, right? Which is once the submit button is pressed and we have added the item to the list and updated the database and displayed the list in the text label, let's also clear the text box, right? So we go to the text box, and what do we need to do to clear the text box? We simply set the text in the text box to nothing. All right. So get set, get set, get set. We keep following this pattern. Get a value and use the set method to update it, right? So get set, get set, get set. So what do we want to update the text box to now? Nothing. We just want to stick empty text in there. Okay, let's see if it's working. All right, so I'm going to add a new to-do. What else do we want to do? Water plants, another favorite. Add a to-do. And this time, you see, once I have clicked on the add a to-do button, I've cleaned up my text box. I've cleared up my text box, and I can keep adding do yoga. attend class, yeah, and all of this is going into my database. So this app is about getting a little more practice with using the TinyDB database component in App Inventor. There is one more unfinished item of business. So adding a to-do, we see that it works. Clear all. I click on that. We still need to program that. Okay, so let's do that and finish up this practice problem. So what do I want to do? When I click on the clear button, I just want to empty the information in the global variable, empty the information in the database until new information starts coming in, right? So basically empty, empty, empty. Empty the global variable, clear out the database, and clear out the text label. And all of this happens when we click the button. So go to the clear button, grab the click event of the clear button. And this is fun. So we want to empty the list. So we can just go to the global variable and set it to empty. So I'm going to set this list to an empty list. So the create empty list from the list drawer, okay? We also need to clear out the database. So go to the TinyDB component. Which tag do you think, which method do you think I need to clear out the database? Yeah. So clear tag. So what clear tag will do is it will look at the tag I give it and then just clean up clean up all the information that's inside there. I will just duplicate the tag from elsewhere in the code. And the last thing I need to do is reset the text label, right? We don't want it to show anything, but we'll also use it to make sure that we have cleared out the database or we have cleared out the global variable. So we'll go to the text label and we could just set the label text to nothing. We could do that. But let's use this opportunity to also make sure that the global variable has been cleared out. So instead of this, I'm just going to grab a getter for the global variable. I see something in the chat box. Hang on for just a second. We'll come to that. We'll come to your question. All right. And so what should happen now is, we should be starting off with a clean slate. Okay. So clear all, and there we go. There's one little issue here. Do you see that it's showing two rectangular brackets with nothing in between because there's nothing in the list? Yeah. So it's telling me that clear all did indeed clear the list. And now I can start all over again. And the hint I had was do my daily kriya, which is basically my yoga. But yeah, you can start all over again and keep adding to the list, get water, what have you, get vegetables here, and go on and clear. So it's working now. Okay, and if you don't like this rectangular brackets, if that's not what you want to show, you could just call the, you could just use the empty text, and that might be visually more appealing, right? So there you go. Okay. So instead of showing an empty list, which is those rectangular brackets, it will just show zero text. So, all right, so let me look at the question. I have a conflict at 4:30, so okay. Yeah, no problem. Thanks for letting me know, Adrian, and good to see you. So I hope that was clear. This practice problem was designed to practice working with TinyDB database in App Inventor, and also a little more practice writing procedures. Now we'll go on to the next one. And before we go on to the next one, let me just make a segue into that. So I've written a procedure here, and that procedure has, speaking from the standpoint of a software developer, it has a number of problems. What are those problems? So one is, there are a number of pieces of information that are hard-coded, right? So it is expecting that there should be a global list called my to-do list, and it will only work with that list. It will not work with any other list. But I might also write this procedure in a way that solves a more general problem. Instead of just working with this exact same list every time, it seems really useful to convert a list to text, isn't it? So I might want to generalize this procedure to work with any list absolutely that I pass to it as a parameter. That is one problem with this procedure, the way it is currently written. Procedures are also called functions in many programming language. And when we say, let's learn how to write procedures in a generalizable fashion, in many programming languages and classes about them, you will learn how to write functions in a generalizable manner. Procedures are synonymous with functions. Do you see the second problem with this procedure? So just like the list is hard-coded, the text element is also hard-coded. We are expecting this procedure to know exactly this particular label's text and work only with that. So both in terms of how the procedure is accepting an input and how it is solving the problem of converting that list to text and returning an output, in both these areas, we have a problem. We have hard-coded how this procedure works. It will work only with this list and only with this text label, right? So in the next exercise, we will practice a little more about how to write procedures in a generalizable way with the same functionality, maintaining a to-do list. Okay, so let me open up the next practice problem. I'll be sharing all of these in the Google Classroom. Sorry, I wasn't able to do that already. Usually I have these up there ahead of time, but yeah, you will be able to access whatever we are doing today. So how to generalize a procedure. Yeah, and let's see how this works, right? So let me refresh, close the chat box, refresh the companion screen. So for all practical purposes, this app works in an identical fashion as the previous one. These are just practice problems. And so again, I could add get milk, and as you can see, my life is a lot of fun. All I do is get milk and water my plants, right? So yeah, maybe let's take it up a notch, go to the disco or something like that. Yeah. Not that we'll be doing that, but okay. And so this works in the same way. So the only difference is in the implementation. And what I've done is I've taken that previous procedure and implemented it to be more generalizable. Okay, and once again, the code is already here, but I'm just going to delete everything. So first of all, let me clean. Yeah, I'm just going to delete everything and start from scratch. So add to backpack, add to backpack. And when you do the practice problems yourself, it's also a good idea to just start from scratch and look back if you need to. Yeah, so delete everything just like I'm doing, put it into the backpack in case you need to look at how it was implemented, but try and do it yourself and then compare with what's in the backpack to see how we did it in class. All right, I think I got everything in the backpack. Yeah, okay, whether it's there or not, we'll figure it out, right? Yeah, so let me just delete all the code and we'll get started. Delete. 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 So much of this code is similar to the previous one, except the way we wrote the function. Let's get rid of everything and start with a clean slate. All right. Yeah, there we go. So what's the first order of business? Save the empty screen. Yes. The first order of business is to create a global variable. And I'm going to go a little faster this time because much of this is just the same from the last time. But wherever we are doing something different, I will slow down again. So what did we do? We went to the TinyDB. We got the value for our tag. And what was the tag? The same as the name of the global variable, my to do, oops. Sorry about that. My to do list, right? And if the value is not there, I want to return an empty list, go to the list over, grab an empty list. So there, that is done, okay? And now the next order of business is writing a procedure. And we're going to do something wonderful this time is we're going to take a procedure which returns a result. And we haven't done that before. In the 3 apps that we've built so far, we've never done that. So this is something new and interesting, right? And we're going to give this procedure an input. So we've done this before. So we're just going to call this, what should we call this input? It's a generic list. So we could just call it my list, all right? And I could pass it any list. It doesn't have to be called my list. It's just a placeholder. And what do we call the procedure? Let's just call it flatten my list, because in computer programming, when we take a data structure like an array, a list or an array, right? And when we convert it into just text, plain text, we call it flattening. We also call it serialization, okay? These are just technical terms. So let's just call it flatten my list. So it's going to take any list you pass it. It could even be an empty list. It could be this list that we have here, my to-do list, any list, and it's just going to return text where every item in the list is just on top of each other. It's just stacked, right? And as before, we are going to need to use a for loop to iterate over every item in this list that we pass to it by list. So this for loop is going to iterate over my list. So I get my list from the function template, the getter and the setter, both of them are here. So I just took the getter and plugged it here. And what do we want to do now? Pretty much similar to what we had done before. We want to start with an empty string. Okay, we want to start with an empty string. So I'm going to need a local variable. So all this happens inside my procedure. So I don't need a global variable, right? I just need a local variable that temporarily stores this information until the function is ready to return it. So I'm going to grab this block from variables drawer and call this just my flat list, all right? And what do we initialize it to? Nothing. So it's just blank to start with. There's nothing. So when I have nothing between these quotes, that means there's nothing in there, all right? And now as I go over every item in the list, what are we going to do? Well, we are just going to update this. So we're going to set my list again using the join method. All right, to join the latest item to whatever is in the flat list. So flat list, this local variable also has a getter and a setter. So every time I will get its current value and stick a new item from the list on top. And let's remember to add the new line. So these will all be separated by, each item will be on a new line. Now, this is identical to what I'd done before, except that now I am not updating the label, you see. I'm just creating a local variable called my flat list, and I'm storing the result there. Okay, so let's plug this operation into the for loop, and let's plug this into the initialize, into the procedure. But you see, there's a problem here, which is this doesn't fit, right? So there's one more step that I need to do here, which is just go to control, I believe, and look for that adapter, which I can use to stick that code block in there. All right. And now we want this procedure to return a result. Okay. The input is my list. It iterates over every item in my list to create a flat text, which it stores in this temporary variable. I can do nothing with this temporary variable unless I return it back to the main program. So that's what I stick in the result of the do block. All clear so far? If you have any question, please feel to type. So what I've done here is I've minted a new Lego brick, as I like to call these procedures. So if I go to the procedures drawers, now I can see this flatten my list. It was not there before. We made it, right? We created it. And what did we program it to do? You see, it expects an input called my list, which is how it will refer to that input internally. Outside the function, I can call it anything I want. But inside the function, once I've passed it that list as an argument, it will call it my list, right? So it changes its name. And on my list, it iterates over every element in the list and creates a nice paragraph of text that we can do whatever we want with. It just returns that paragraph of text. All right. And what do we want to do with it? So when we go to screen, we find that screen initialize that we had used before. Where is it? Here it is. What we want to do with this is just we want to display. We want to use this procedure to take my to-do list and display it, right? So this time, what we'll do is we'll go to the text label. This is the display label, and we will set its text property to what? To this my to-do list. But before we can stuff a list into a text label, we need to convert it into a flat list. So we will just use the wonderful procedure that we created, pass it the to-do list in whatever shape or form it exists. It could even be empty, and then show it there. All right. So you see what is happening here? Yeah, I've created a generic procedure, a very general procedure that works with any list to flatten it. And now I'm using that to show to update the text in my text label. There's more work to do, but let's see how we have done so far. Okay. So initialize the screen. So right now, refresh companion screen, there's nothing. The database is empty. We cleared it in the last example that we worked through, right? So there's nothing in there. And now let's start adding elements to the list. So this is pretty much similar to what we had done before. Go to the submit button. A new element gets added when I click on the submit button. So grab the click event of the submit button. What should happen here is that the global to-do list is updated. To update a piece of information, we grab the setter. And yes, this is a list. So we go to lists and we grab the block to add items to an existing list. So actually, we do not need a setter because the add items to the list operates on a list, and it will do that for us. It will, yeah. So we just need to tell it which list to update, and it will grab the item from the text box. Here we go, a text in the text box, all right? So whatever I put in the text box, get milk, water my plants, go to the discotheque, exciting, boring, whatever is in there, it just got added as a new item to this list. And since this is a list, we don't worry about this separator, right? When it was text, we were interested in putting a new line, sticking a new line between every item. In a list, these are just items that sit next to each other in a list. So there we go. The only change we might want to make to this is check if the item in question is blank, but I'm not going to worry about that right now. Yes, and not only do I want to add that item to the list, every time I click on the button, I also want to show that item. So now we know how to do that. Just duplicate this code and set the label text to whatever it is in the list. I also need to update the database. So as we did before, we'll go to the tinydb component, grab the method to store the value in the database. And then I'm just going to copy the tag and copy the getter. All right. What do you think this will work? Yeah, we never know, right? Okay, let's see. So back to getting our milk. So it didn't display anything in the label, right? Flatten my list, my global to-do list. Let's just go through the logic again. I have my list. Did I pass it my list? Yes. If there's something in the list, I'll start with an empty list. When I click on the submit button, take the item in the text box, add it to the list, then set the label text to global to-do list and store the value in the database. Yes, so that should work. Let's try one more time. If you see any issue with the code, let me know. Code can be a bear sometimes. Yeah, so something interesting is going on. It's not working for each item in my list. Have I passed it my list? Call flat my list. Global item list. Create an empty list. Let me just have a quick check back with my code in the backpack. Okay, this is why we put code in the backpack. Generalize do. That seems to be just dandy. My flat list. Am I setting the label correctly? Yes. Store value. Yep. Submit button, click. You just check one thing about. Yep. Flatten my list, store value. Tag. The code seems to be quite all right. The only, let's give this one more shot, otherwise we'll circle back to it later. Connect. All right. There's one way we can debug, which is calling flatten my list. We can use a notifier component. I'm going to drag and drop it over here. Go back to my blocks. When I click on the button, let's just use the notifier to show us what's in the list already. All right. Let's just hope. Yeah, flatten max. So let's print in the notifier what we are seeing there. It's useful to know how to debug our code as well. So let's give it a shot, and if let's try to just debug it. Debug. Next, okay. Flatten my list. For each item, join. Refresh. Debug my code. All right, debug. So there's nothing showing up here. So that means the flaw is in the procedure to flatten my list. Let me just try showing the list itself. refresh, do something. Yep, so the list is working okay. And the problem is with, there's a lot of elements in the list actually. The problem is with how I've implemented the flatten. All right, so let me give it one more look, and if I can't solve it, I'll get back to you on this via the Google Classroom. Each item set flatten start doing. Just compare with what's in my backpack, okay? Initialize the local. Do for each item of list. It is my input list. My list here. Yeah. So at this point of time, let's just move on and circle back to this later. Okay. Sorry about that. I have to get through a bunch of these practice problems today. So let's just drop this off here and we'll come back to it via the Google Classroom, I promise. On the face of it, I cannot see what's holding this up. Another thing I could quickly try is just plug in the notifier here. But yeah, I'll just end up taking a lot of time. So I'll come back to this later. Sorry about that. Let's go on to the next practice problem. How do we make a ball go back and forth? So I'm just hitting the pause on this. How do you generalize a procedure? We did implement the procedure and there is a bug in this code. Give me a little time to figure it out and we'll get back on this. All right. We do need to get through all of this today. so how do you make a ball go back and forth? Let's go to that one. Maybe by the time we come back to this, we'll have some fresh ideas. So we'll just hit pause. All right. Okay. So in the last game, we also looked at animation and basically a number of different ways that we can animate image sprites on a canvas. What happens here is there is a ball and it goes from the left to the right of the screen, and each time it reaches the edge, it bounces off. So let's see how to program that. And this is just a little more practice with using the image sprite and the canvas. And in the app, I basically just have a canvas with a ball and a clock, right? So this is practice with animating a sprite using a clock and a timer instead of the internal clock and timer, which also we have seen in the last class. So I'm going to move all this code to the backpack and delete it. Go to the backpack, yeah, and delete it. All right. So starting off from a clean slate, the ball, yeah, will stay wherever we refresh the companion screen. Yeah. So the ball's just going to stay wherever we stuck it and it's not going to move. So the first thing we'll do is define a global variable that is actually the speed of the ball. Okay. So I'm going to call it V for velocity X because the ball is only moving along the X axis. And this speed, if you remember from the app that we built, is just the size of the step that the ball takes at every time interval in pixels. So I'm just going to set it to a small value like 5. And it will step by 5 pixels in the X direction every 50 milliseconds. Okay, that's the clock component's timer interval property. I've already set it to 50 milliseconds. A millisecond, remember, is 1,000th of a second. So now how do we make the ball move under the control of the clock? So we'll go go to the clock component and grab the timer, as we have done many times before. And when we animate a sprite under the influence of a clock, under the control of a clock, we manually reset the X and Y coordinates of that sprite every time the timer fires, every time the alarm on the clock goes off, right? So we basically want to set the coordinates of the ball. So let's go to the ball component and grab the setter for X. So this ball is just going to move along the X axis, hence X. And what we want to do is every time we want to set the new location of the ball along the X axis to its current location plus the velocity X. So go to the ball again and grab its current X location. And then let's do that little bit of math, which is addition, the current X coordinate plus the velocity Vx. This is going to be the updated location. So when we do this, what should happen now is, the ball from starting from wherever we position it, it just moves all the way to the right. It hits the right edge and it stops, right? But what we really wanted to do is we wanted to bounce. So how are we going to do that? So in the last app that we built, we had used the built-in bounce method. Here we are using a timer. So we actually need to write that piece of code ourselves. And it's when the ball hits the edge that we want it to bounce. So when I go to the ball, there is a edge reached event. Let's grab that and see if we can use that to make the ball bounce off. So the edge reached event works off any edge of the ball. That's why it will also tell you which edge. We don't care which edge. So it will work for any edge once the ball has reached it. And what we will do here is a little trick, a simple little trick where we will just flip the sign of the velocity to negative of what it was. So if it's positive, then turn it to negative. It's negative, we turn it to positive. So to start off with, it's a +5. So here we are going to flip the sign to make it -5. And how do I do that? How do I flip the sign of a number? I just multiply it by -1, right? So what we'll do is we'll set the velocity to a new value, and that's going to be minus of the previous value. So grab a constant -1, and whatever is the current value, I want to multiply that by -1. So if it's +5, it's -5. If it's -5, it will flip it to +5. And with that, when it reaches the edge, suddenly it's not stepping forward, which is +5, but it is stepping backward, which is -5. So if all goes well, then now I should see my ball bouncing. And here it's reached the left edge and it bounces off that, and it reaches the right edge and it bounces off that, okay? So this is how we make the sprite bounce at the edges of the ball. Any questions so far? It was a simple little demonstration. All right, and next we're going to look at how do we make the ball bounce off edges and objects, not just an edge, but also other objects. Before we wrap up for the day, I'm also going to show you how to make the ball move under the influence of gravity. So let's keep going. So the next practice problem is how to make the ball bounce off edges and objects. And in this practice problem, I have this spaceship. Let's hit start. Yeah, so the spaceship just hits the ball and it bounces off it, and the ball is stationary. And if I make the spaceship go sideways, then it's going to bounce off the edge. So it's a very simple practice problem. Yeah, let's see how to implement it. So again, I'm going to get rid of all the code. A lot of things in the backpack. It's reached. Yes, here we go. All right, let's start with a blank slate. What does that look like? We just have the alien spaceship and the ball. Let's make the ball a little bigger. Save the empty screen. Let's go to designer. Yeah, that's all there is. There's a canvas component, a ball. Let's make that a little bigger. There's the radius property. Let's make it 21. Okay, there it is. So it's easier to see. There's an image sprite, which is set to show this little alien ship. And that's it. And there's a start button. And this time we are not using a clock. Instead, we are relying on the internal clock that every sprite has, right? So let's just make sure that that is enabled, yeah? And if you remember from the last class, the way we manage the trajectory, the motion of an image sprite using its internal clock is by first enabling the internal clock, which is checking this enabled box here, and then setting the 3 properties, right? Speed, interval, and heading. Heading is the compass direction, speed is the size of the step, and interval is the time in which it takes that step. So everything is kicked off when we click the start button. So let's go to the button and grab its click event. Nothing happens until we click on the button. Let's go to the image sprite and grab its heading. Where do I find the heading? There we go. I'm going to need the heading, I'm going to need the speed, and I'm going to need the interval. There we go. Okay. And to start with, let's just make it bounce. Let's make the spaceship travel from left to right, right to left. So let's just make it bounce off the side edges, okay, to start with. Then we'll come to the other object. So what is the heading that represents the compass direction of east, right? So if you remember from the last class, east is 0, north is 90, west is 180, south is 270, right? So let's set the heading to 0 because we want it to travel east. Let's set the interval to 50 milliseconds. And let's set the speed to 10 pixels. Okay, so it's going to jump 10 pixels every 50 milliseconds heading east. All right. So first, just let's make sure that that works. So it's a good idea to go step by step and click on the start button there. It goes off to the east and reaches the edge and it stops. And this time we'll use the bounce method. So let's go back to the image sprite. Let's grab the component for edge reached. It doesn't care. We don't care which edge was reached. So just as soon as it reaches an edge, we will program it to bounce off that edge here. And this time, we will just use the bounce method that is that is available with every image sprite. Okay. We do need to, the bounce method does need to know which edge you want to bounce off. So we'll grab that from the get edge. Okay. And so now at this point, my spaceship should happily bounce. And you see it flips over when it bounces. It's kind of cute. Okay. It's bouncing off both of those edges now. All right. So fresh companions. There we go. The last thing we'll do is just make it bounce off the ball. And for that, we want the spaceship to travel down, right? So what is the heading for traveling south? So when it travels south, it moves towards the ball. So that heading is 270. Okay. And what happens if I just do that? Let's check that out. Click on the start, hit on the start button. It's just going to go right past. Yeah. So we want to change that and we'll see how to do that. So this time, go back to image sprite. And now since it is hitting another sprite, a ball is basically a sprite, we need to use the collided with event. So we'll grab the collided with event. This event will also tell me which was that other sprite that it collided with, but we don't need that in this instance because there are only two sprites in our entire practice problem app. So yeah, so unlike for the situation, unlike for the scenario where the sprite reaches an edge, where we have a bounce method, when the sprite collides with another object, with another sprite, there is no such bounce method. So we need to hand code it. And it's not that the math is not complicated. All we do is update the heading to a new heading. And what is that? So first of all, let's grab the setter for the heading to set the heading to a new value. And what's the new value going to be? So the math of that works out to 360 degrees minus the current heading. Okay, you can just investigate that yourself if you want to. So 360 minus the current heading. And where am I going to get the current heading from? Well, that's a property of the sprite. So go to the sprite and look for the getters and setters and find a getter for the current heading. And that is it, right? So puts this whole block to set the heading to a new value, and it goes into the collided with event handler. So now refresh the companion screen, make sure we're running our latest code. When I hit start button, should be moving south and it bounces off the ball and bounces off the edge. Okay, so just a little more practice operating a sprite under the control of a clock and then having it interact with the edges of the canvas and other elements around it. Now, in an app like the ones we have seen so far, like if you remember the Temple Run app that we built, we were using a dozen different sprites, right? And so we needed to know whether the sprite that our runner was colliding with, was it a gold coin? Was it a reward? Was it a bone? Was it a trash bag, in which case there was a penalty, right? So we had over a dozen sprites, and this is where the only difference is we use the other to identify which sprite it collided with. So we can also program this collision event to execute different branches of code depending on what was that our sprite collided with. So we can program it like that. This is just a reminder. So when you go back to that Temple Run app and have a look at its code, I think then this will help make sense of that. Okay, where are we? How do you store it? Okay, this is the last bit, right? So I did want to show you this gravity pong app, but I think we can do that another time. Let's go back to store information persistently. Let's go here. Right. So what happens in this app? So this is an interesting app actually, and a little challenging to demonstrate via the emulator. So the Android phone that I have doesn't have a SIM card, but what this app does is when you receive a text message, say you're driving, right? And you receive a text message, an incoming text from a friend. This is kind of the text equivalent of voicemail. So if you're driving and you receive a text message, it will tell the sender some message, and we can configure what that message is. It's customizable. Okay, so that's what we're going to see how this is implemented in this app using the TinyDB component. Yeah, and this time I'm not going to delete all the code. In fact, I think I'll just delete the TinyDB component and see what that does. Take off the, and I think I might just leave it here. Add this to backpack, this to backpack. Right, so I'm not going to delete all the code. I'm just going to delete the TinyDB component. right? So the database is gone. So some of the code blocks will have gone too. So any code block that was using the TinyDB component is now gone. And let me explain what is happening here. So let's start with the designer. So there are text labels that just show text. So this label here, label 1, is just showing send the following message in response to all incoming text. So this label just has that long string in the text property right here in the designer. And then label number 2 is actually the message that we wanted to send, which could just be I'm driving, chat later. Yeah. So the default value here for this, there is no default value. It's empty. So it's just saying your message here. Actually, the label 2, I'm sorry, my apologies. Label 2 is just a blank label to separate this label from this label that says your message here. And the outgoing text label, that's the one that shows whatever message you want to send to the incoming, right? So right now, I've just set it to say your message here. Then there is a outgoing text box. This is where we can type in a new message. So a message like your message here, that's not going to make a lot of sense. So whatever message we want to send while we are driving and receiving incoming text, whatever message we want to send to the incoming, that we customize it using this text box. And then when I type that message in here and click on the change outgoing message, that's going to be my new message that will be displayed here and it will be sent to all the incoming. I hope that makes sense. I know it's very wordy. Yeah, this is a little challenging for me to demonstrate because like I said, my Android phone doesn't have a SIM card. And in the emulator, there's only so much we can show, but let's give it a try, okay? Let's also look at the code. Yeah, so let's see what happens if we do this right now. So screen initialize, I'm going to have to actually, when I deleted the TinyDB component, there are some errors, right? So let's just look through the code while we fix those. So this uses a texting component, right? So go back to the designer. So under the screen, you see the texting component. And where did the texting component come from? So I believe it came from, was it social? Yeah, so it comes from social. Oh, not social, sensors. Show connectivity, not there. It's got to be social, right? Yeah, it's under the social drawer. And so this will work on any Android device. It will work with the underlying operating system, Android, and it will, when you receive text using the built-in texting app on Android, not any other texting app that you install like WhatsApp or Telegram, but with the built-in texting app that is distributed with every Android operating system, then you can access that text, so that is usually linked to your phone number on that phone. It can access that, and it can also help you send text messages to phone numbers in your contacts list. And using the texting component, once we have it as part of our app, so after having dragged and dropped it to the screen, is very simple in the sense that you go to the texting component, it has only one event, message received, right? And so everything is triggered by receiving an SMS message. And when you receive an SMS message, you also get not only the text of the message, but also the number. Yeah. And so then by setting the phone number attribute of the texting component to the incoming number, the number of the incoming message, and the message property of the texting component to the text label, which is whatever we want to say, right, in response to this incoming text. Then we just use the send message method, and it will send that message to this number and with this text in the message. All right. So using this is just a matter of using the texting component and the message received event. There's nothing else you need to worry about. But what we want to do here is basically when we click on the button, we just want to take whatever is in the text box and we want to send that, right? So I want to grab the text that is in the text box change the outgoing text label and reset whatever is in the text box, reset the text box, and that becomes the message that I'm going to send, right? So when I initialize the screen, this is going to be my default message. I'm just going to type it in here. I'm driving. And later. Okay. All right. So if I've done this right, what should happen is refresh the companion screen. The default message appears here. And now I can change that, right? I could just make it, let's say I'm just going to make it all caps. I'm driving. Change outgoing message. So, okay. So in the emulator, I can demonstrate this part of it, right? I cannot actually demonstrate sending and receiving text messages because the emulator is running on my Mac. It will not do that. But if you download this app to your phone, it will not only just the button will work, but it will also send the messages that you type in here. All right. So it's kind of a text version of the voicemail, like I said, and let's change this to something else. If you have any suggestions, put them in the text box. Maybe, yeah. I'm not very imaginative, so talk later. So I don't know. I'm programming, talk later. I'm coding. Wow. It's about how social I can get, right? So change outgoing message. So we can keep changing that, right? And what is the drawback of this, right? So the drawback of this app and the way I have currently implemented it is that anytime I close the app and restart it, it's not going to remember what was the message that I changed it to. Yeah. So there is a default message which I've hard coded, but it won't remember what was the message where I left off. So I change it to I'm coding later. And I change it to this. Yeah. And I close the app and I start all over again. I launch the app the next time whenever I do that. So I can simulate that in the emulator by just refreshing the companion screen. It doesn't remember that. So it doesn't persist that data. And by now we know that's what we use a database for, right? To remember things beyond just a session in which we use the app, right? So that is a part that we're going to add using the TinyDB component. And so this is the last practice problem for today and using the TinyDB component. So where do we find the TinyDB component? Go to storage, grab TinyDB, drag and drop it to the screen. Yeah, and now that we have the component, yeah, when I click on the click button, what I'm going to do is just save that new message into TinyDB. And that way I can persist it for longer than just when the app is running. Makes sense, right? So go to TinyDB, and to save something to TinyDB, I need the store value block. So now I will be putting that new message into the database. And I need a tag, right? We already worked with a tag in the last. I'm going to use a simple tag like message. And what do I store in there? Whatever is in the text box, which is the outgoing text box, text value. Whatever is stored in the text property of outgoing text box, right? Yeah, so now this value will be stored in the database. Now it will be persisted, but that's not what's going to be shown yet, right? Because we are still showing values that are not generated from the database. Nowhere are we querying the database with this tag message and saying, show that what's in there. Yeah. So when I initialize the screen, what I need to do is instead of this default value that I just put in there, I grab that value from the database. So these are really simple changes, right? So go to the TinyDB component. Which method do I want to use? The get value. Which tag do I want to use? The message tag. And what default value do I want to use if that database doesn't recognize the tag? whatever default value we had before. Okay, so yeah, so now every time, let's see what's the logical flow here. Every time I launch the app, the first thing that happens is the screen is initialized. And now in the initialization procedure, it's going to show text, which is whatever was in that, whatever I have in the database with the tag message. And I can keep updating whatever is in under the tag message using the text box and clicking on the button. So every time I click on the button, TinyDB is updated with a new text message. This we can verify, although we can't close the app here. So it's just let's just refresh companion screen and see what happens. So this is like in the emulator, refresh companion screen is like restarting the app, right? So yeah, there is nothing under message. That's why it's showing blank. But this also tells me that it did query the database. So let's add some message here and writing. Change the outgoing message. Yeah. So now it's showing up. So this is all I had for the practice problems today. Any questions?